Hi and welcome to RFree 104, where we're going to talk about how to manage prohibited zones. This really means how we're going to make them bigger or smaller as we need them to be bigger and smaller. Prohibited zones are the area around your antenna where you have to demonstrate to the FCC that there will be no population because people inside that zone would receive interference from your radio station. So let's get started. We're going to use our familiar example in Farmington, New Mexico. This is actually from RFree 103. And in this example, we're going to focus on the frequency 94.3. It's a yellow channel. It might be available, but it has a prohibited zone. It's 83 meters. And for the purposes of this arbitrary example, let's say that we cannot handle an 83 meter prohibited zone. That's not unusual. That's a pretty big distance. I want to actually point out some bits in the pop-up, this part in particular. You can reduce your prohibited zone. Whoops. And you can lose it off the screen too. Okay. You can reduce your prohibited zone by raising your antenna. This is because when you raise your antenna, you have to reduce your power. If you're raising it over 30 meters of height above average terrain, you have to reduce your power so that it can't go any further than it would if it was 100 watts at 30 meters. So when you reduce your power, that makes your prohibited zone smaller, because your prohibited zone is all about how strong your station is in relation to the station, another station that somebody's trying to listen to. You can also move your antenna closer to the other station. Why does that work? Because the strength of that station gets higher. That means that somebody trying to listen to that station, as you get closer to that station, is going to have a better chance of hearing that station instead of interference from your station. And then the third method is using special antennas. And we're going to talk a little bit about that so that if you end up using an engineer, you'll understand what they're talking about. But we're not going to go into tremendous technical detail there. Now, like I said, we're going to focus on 94.3, which has a prohibited zone of 83 meters. Now, I want to show a view that's from a part of RFree that I haven't talked about. It's in the advanced section, but this is a good map to show what's going on. Here is the station or the antenna location that you're proposing in this example. This little blue dot over here is a station K230AF. It's a translator. It's a fairly low-powered station. And you can see how far away they are. For the purposes of this discussion, ignore the red and the blue areas. So this is the relationship. So one of the ways that I said that you can reduce the prohibited zone is to move your antenna closer to the other station. And I'm going to do that. Actually, I've already done it in advance so that we can see the results quickly. Here on this screen, the prohibited zone is 82 meters, same as on the other page. And when you move it closer, here's what you get. You see how that's closer? Okay, so we moved a couple kilometers closer. Now the prohibited zone is 46 meters. Obviously, you could move this to right on top of the other station, and the prohibited zone would shrink to nothing. That's sometimes what you might need to do, but it's probably not as recommended as staying some distance away if you possibly can. Now, that's one way to do it. Another way to do it is to raise your antenna, and this is an interesting example. Using this example where we've moved our proposed antenna location, if we look at the channels available, everything's still available just like before. The PZ for 94.3 is 46 meters, just like we saw. And over here in the antenna height, something interesting has happened. To get 30 meters height above average terrain, the antenna has to be underground by 16 meters. Now, you don't want to dig a well and put your antenna in it. It's really not going to work very well. So the better idea is to raise your antenna up above the ground. But know that the calculation was made as though it was possible for an antenna to be at minus 16 meters underground. And that's what produced this contour, and that's what produced this prohibited zone. So let's raise the antenna. Let's raise it to ground level, let's say. That's still not where you want to have the antenna, but let's raise it to ground level to see what happens. So let's change that from -16 to 0. We'll hit OK. Oh, I guess it has to be positive. Let's put it at 6 meters, which is about 20 feet. That's a nice level. And here you can see, here's your current antenna height. It's at 6 meters. It's going to be 33 watts. The height above average terrain is 52 meters at that spot. That's 22 meters more than it was, right? Because we started at 30 or -16. Now we're at 52, which is 6 above the ground. So we went up 20 meters. And let's see what happens now. I'm imagining that RFree might be having other users at this time. Sorry for the delay. It's doing quite a lot behind the scenes. And here we go. 94.3 had a 46 meter prohibited zone. Now it's 27 meters. Now, interestingly, we went up by 20 meters. We raised our antenna 20 meters, and our prohibited zone went from 46 to 27. One of the nice things to think about here is that you get kind of double the effect of raising your antenna. So if you're in a location where you can raise the antenna, it's a good strategy. If you're in an urban area, you don't want to raise the antenna so far that the power goes below about 20 watts, but in most other areas you can raise that antenna. You'll get better line of sight, so you'll get a better signal anyway, and your prohibited zone goes down pretty fast because your power is going down. The other way, option 3, using special antennas. How does that work? Well, the first thing you need to know is that it's a highly expert calculation that you're going to need. You're going to need information from the antenna manufacturer and things like that, and it's beyond what RFree can do. But let's give a look and see what's happening. That red dot represents your antenna, and this sphere around your antenna represents the strength of your signal. So the strength, it's sort of the distance to a specific strength, and it's the same in all directions. It's a sphere. This is called an isotropic radiator, and it's kind of a good engineering approximation. RFree uses this engineering approximation when calculating the prohibited zone. So again, imagine that's your antenna. This says that your antenna sends as much energy up as it sends down, as it sends in all directions. Real antennas, however, don't do this. This is a classic dipole antenna. It's about 1.5 meters from end to end for the frequencies we're talking about, and it's split in the middle. Here's another picture of one. It's the same sort of thing. It's not connected, that's just the cable hanging off, it's not part of the antenna. This is a dipole antenna, this is a dipole antenna. This is probably one of the most venerable old antennas you can find. They tend to be inexpensive as well. Instead of looking like a donut though, this antenna, which is probably the simplest, cheapest antenna I can think of, has a radiation pattern, well, it looks like this. It looks like a donut. So instead of sending as much energy up as down, it sends most of its energy out towards the horizon and somewhat less in these directions, and theoretically 0 towards the ground. Here it is in 2 dimensions. So lots of signal off in this direction, very little in this direction. What this means is that since the signal isn't going towards the ground with the same signal strength, like perhaps if this was a sphere, it might be going down to here. That signal going to the ground is what pushes out your prohibited zone towards the ground. So by using a dipole antenna and other antennas, we'll get to it in a minute, it essentially flattens your signal area so that it doesn't send so much energy to the ground. That means that the prohibited zone, the interference zone, doesn't get as close to the ground. And you can do some sophisticated math, some trigonometry and such, and work with this pattern and figure out how much higher the prohibited zone comes off of the ground. This is for those cases when you want to make that case to the FCC that the prohibited zone doesn't touch the ground. And like I said, well, the dipole antenna is probably the most ubiquitous realistic antenna that people might use, but there are plenty of other antennas that are commonly used in broadcasting. For example, this is a 2-bay dipole antenna. Now, bay is just a fancy word that means one, okay? So here's a dipole antenna just like the ones we saw before. Here's another dipole antenna on top of it. The signal comes in, you split it and send half to each one of these antennas, and this makes the pattern that we saw, this donut, even flatter. It's getting closer to being a pancake, okay? And you can buy these antennas, and you can also buy antennas like this. This is a commercial 4-bay circularly polarized antenna. 1, 2, 3, 4. You can see this is on a massive tower, and this antenna can have an even flatter signal characteristic, more like a pancake than the single dipole or the double dipole, the 2-bay dipole. So these are the kinds of antennas. They range from not terribly expensive to very expensive, and the calculations that you need to do to supply with your application to the FCC are quite sophisticated. It's beyond what RFree can do. If you're going to need to go that way, if your prohibited zones are just too large to manage in the site that you have, and you need these special antennas, contact an engineer that's used to doing this kind of work. So that's it for RFree 104. I'm Paul. I work at the Prometheus Radio Project. I'm the author of RFree, the software we've been using. Thanks.